All right, class. One thing I forgot to mention when we're doing Lewis structure is when you draw Lewis structure for hydrocarbons, there's a different approach that we can take to it instead of counting the electron. So first of all, what are hydrocarbons? We've talked about this before. Hydrocarbons are compounds that are made of nothing but carbon and hydrogen. They have some number of carbon and some number of hydrogens in them. Now, hydrocarbons are a big deal because hydrocarbons are fuel. Any kind of fuel that you ever use are hydrocarbons. So when you go get gas for your car, what are you really getting? You're getting hydrocarbons because gasoline is hydrocarbons. So next time when you're going to go get gas, instead of saying, I need to go get gas, you can say, oh, I need to go get some hydrocarbons. Now, you're probably going to lose a couple friends over that, but hey, you can be cool. When you want to make barbecue, propane, right? You use propane to make the fire going. What is that? That's hydrocarbon. So any kind of fuel you have, they're usually hydrocarbon. Now, here's the way to look at it. What I need you to remember is that carbon makes 4 bonds and hydrogen needs 1 bond. And I need you to really, really remember that carbon makes 4 bonds, hydrogen makes 1 bond. And everything will be around this. Especially when you move on to Chem, I need you to remember this. Okay, now we're going to start doing a bunch of practice problems. The first one we're going to do is CH4. Okay, so carbon is going to go in the middle and I'm going to have 4 hydrogen around it. Now in this compound, does carbon have 4 bonds? 1, 2, 3, 4. Each hydrogen has 1 bond? Yes. Carbon is happy, hydrogen happy, we're good. What's the geometry? Tetrahedral. We've gone over the geometries. Now I'm actually going to pull up the geometry sheet for you one more time. Here's a geometry sheet, okay? So if you look at it again, carbon, 4 bonds will be tetrahedral. Okay. Now, what is the bond angle for tetrahedral? We never really went over the bond angle, but a few ones I want you to know that tetrahedral is one of the bond angle you should know. The bond angle is 109. The bond angle is 109. So that's CH4. Okay. The next one we're going to do is C2H6. Okay. C2H6. I have 2 carbons. What I want you to do, attach the 2 carbons together. All right. Now, I have 6 hydrogen, which means each carbon gets how many hydrogen? Means each carbon would get 3 hydrogens because I have 6 of them. Okay. Now, is each carbon happy? Yeah, this carbon is happy because it has 1, 2, 3, 4 bonds. This carbon is happy. It has 1, 2, 3, 4 bonds. So each carbon is happy. Each carbon has 4 bonds. Hydrogen, each one has 1 bond. We are good. So go based on that. Now, what is the geometry around each carbon? The geometry around each carbon is still tetrahedral because each carbon has 4 bonds. So the geometry around each carbon is tetrahedral. I need you to remember this. Okay. So far, so good. Now, next one is C2H4. Okay. Again, I have 2 carbons. I'm going to connect them to each other. Now, I have 4 hydrogen. So each carbon gets how many hydrogen? Each carbon gets 2 hydrogen. Now, is each carbon happy? No. This carbon has 1, 2, 3 bonds. This carbon has 1, 2, 3 bonds. When we're doing a hydrocarbon, all I need you to remember is that carbon, 4 bonds. Hydrogen, 1 bond. So carbon is not happy. It needs 1 more bond. What do? Make a double bond. Make a double bond. Okay. And that would be my C2H4. What is the geometry? What is this geometry? Let's go back here. So geometry around each carbon. So each carbon has 1, 2, and it has a double bond, right? We do a double bond and triple bond. Again, they don't they don't affect the geometry, the Westward geometry. So 1, 2, 3 things around a carbon. So the geometry would be trigonal planar. The geometry around each carbon would be trigonal planar. And the bond angle, so tetrahedral had a 109 bond angle, trigonal planar had a 120 bond angle. These are the only ones I want you to know for the exam, the one I'm going over right now. Now, C2H2. Pause me and do this on your own. Okay, probably what you did, you go, okay, I have 2 carbon. I want to attach the carbons to each other. Do that every time. I have 2 hydrogen, which means each carbon would get a hydrogen. Okay. Now, is the carbon happy? No, each carbon has 1, 2. Each carbon has 2 bonds. It needs 2 more bonds to have 4 bonds. So what am I going to do? I want to make a triple bond. Okay. What's the geometry? The geometry is linear. And linear had a bond angle of 180. I need you to remember this when you move on to organic chemistry. Okay? All right. So, what did we do here? What I showed you is carbon-carbon single bond, carbon-carbon double bond, carbon-carbon triple bond. And you do this just based on, you don't need to count the electrons. You can also just count the bond. Carbon has 4 bonds, hydrogen has 1 bond. All right? Now, here's what I want you to remember. That carbon-carbon single bond is longer than carbon-carbon double bond. And carbon-carbon triple bond is the shortest one. So, the way I drew it, I kind of exaggerated a little bit, but this is the bond length. The bond length is higher for carbon-carbon single bond, and then the double bond, and then the shortest one would be carbon-carbon triple bond. So, what does this mean? The triple bond would be the shortest. It would be the shortest, but it would be the strongest. It's a lot harder to break a triple bond than a single bond, because you have 3 layers to break it. So that this would be shortest but the strongest. This would be longest but the weakest among carbon-carbon bonds. So carbon-carbon bonds, hydrocarbon, I have nothing but carbon and hydrogen. Go based on carbon needs 4 bonds, hydrogen needs 1 bond, and then count the bond, and then go from there for hydrocarbons. Okay.